Hello, everyone, and welcome back to another Silicon Labs product podcast. Today's podcast is going to focus on our timing products. I'm excited. I know Isaac Sanchez is the normal voice of timing, but it's been a while since I've talked to my buddy Kyle Beckmeyer. Kyle's the senior marketing manager in the timing business unit, and his primary focus, as he's going to talk about today, are some of the new automotive solutions. So, how's life been treating you, Kyle?
Well, life's been good. We're staying safe and healthy, and I hope everyone else is too. I'm looking forward to getting my vaccine here shortly, and things will progressively get better from there. Hopefully, the same for you.
Yeah, hopefully. I mean, we've worked together for quite a while, haven't we?
Yeah, I remember easily 10 years ago. Our first time together was on the golf course when I was at IDT, and I think you were at Avnet at the time.
That's correct. Yeah. And I was going to tell you that you might not even know this, but my first experience with Silicon Labs was way back in 2003. I was still a design engineer out in the Bay Area. And I don't even know if you know this, but I designed in the 5364. It was a Sonnet synchronous timing chip. And it was so cool. I was, pretty much a new design engineer. So to work with that type of a timing chip was crazy. It really taught me how complicated timing solutions can be. Well, okay, let's just jump right into it, Kyle. I have some questions for you. So, all right, my most important question is, how does it feel having the same name as me at Silicon Labs? Has it been a positive or has it been a negative experience?
Well, I believe I joined the company after you did, so you set a pretty high bar that I quickly realized when I joined the company, but it's been nothing short of fantastic. There's not many Kyles in the world, and there's certainly not many in our industry. So I'm glad we have the same high degree of excellence for all Kyles worldwide.
We have to uphold the Kyle name. So kind words, Mr. Kyle. I definitely love working with you too. So, all right, jumping into the serious questions. You are, as I mentioned at the intro, involved in the automotive and the timing solutions. And I keep seeing your presentations where you're talking about AEC Q100 certification or, stamped AEC Q100. What does that entail? I mean, what really is required for a semiconductor solution to meet that automotive requirement?
Yeah, it's a good question to start off with, and more specific to a timing device as well, because there just aren't many AEC-Q 100 timing solutions available in the market today. We saw that as an opportunity for us when we started seeing customers ask for our devices in automotive. And really what AEC-Q 100 means is, the minimum bar needed for a typical automotive customer to use a device. And it really has to do with the level of quality associated with the device, because in automotive, they're always pressing for 0 ppm and having a really high degree of quality associated with your device. And so to get into a little more detail, what that means is it's really from start to finish, from the design to the manufacturing and into production. And so for our initial family of products, we were lucky enough to have an existing product family, the 5332, that was designed very robustly from the beginning. It wasn't originally intended for automotive, but we quickly learned that we could take that existing design and go through what's called an AEC Q100 qualification. And that is really taking the die as well as the package and submitting it through an extensive list of qualification procedures to meet those AEC Q100 standards to make sure it's robust and has a high degree of quality associated with it. Part of that process for us meant that we submitted the die to a full recharacterization. So for those of you who have been with us a while, the 5332 family was initially launched to the market as an industrial temperature grade product. And about 2 years later, we started that re-characterization process to the automotive standard. So we kind of started from ground zero when we did the automotive grade family with the existing die. So we did a full re-characterization of the product from -40°C up to 110°C. So over a wider temperature range to match the automotive grade 2 temperature range. And then in addition to that, there's a lot of steps involved in terms of the qualification of the package and the package die itself. And then thirdly is the testing of the device. So the iTemp device and the automotive grade equivalent do not go through the same testing procedure. The AEC Q100 automotive grade version goes through a much more rigorous production test system as well as environment. And then lastly, for our AEC Q100 products, we actually use what's called the automotive flow in the manufacturing of the wafers at our partner TSMC, which is separate than the standard industrial temperature grade flow. There's more product quality checks along the fabrication process. And then also in the packaging process, our partners have what's called automotive flow. And so we also elect to use that in our AEC Q100 product portfolio.
All right. So it sounds like you're just making sure for automotive customers that every step of that product's life cycle is accounted for, documented, completely, sound and tested, right? So
that's right.
Automotive customers, they have to be able to fall back on all of this documentation to prove safety and that it's going to meet those requirements.
That's right. High visibility on the overall quality of the device and driving towards that zero ppm mentality of ensuring that a bad part doesn't ever get shipped to a customer.
And it was interesting. You mentioned that just the 5332's history and the way it was designed, it speaks to all of our ICs, but for you to have one that was so well designed in the front end probably reduced a lot of the rework and the redesign that had to be done to provide customers with that AEC Q100.
Yeah, it's really what allowed us to get to market extremely fast. And so everyone was giving high fives when we got through the first couple of gates in terms of the qualification process and realized that, hey, this design is much more robust than we had anticipated, and it already meets the level of quality needed for an automotive type product. So we got the full thumbs up and go ahead to move forward with the recharacterization and the qualification process without having to put a whole lot of R&D into the device and doing a separate development.
Well, it's good that we shared with the listeners sort of the differentiation between some of these automotive solutions. And we'll talk about some of the special features now that you're adding, but just the base requirements for those parts is good to talk about first. But now, why don't you talk about the growing demand that you're seeing? Because every time there's a company report or you and I sync up, I'm hearing about more and more timing solutions being really asked for by automotive customers. Can you talk about why you're seeing automotive customers more interested in seeking out some of the timing solutions that we specialize in?
Absolutely. Yeah, and this is how we got into the market as well. It was based on customers coming to us and asking for automotive grade solutions of our products. And really what it comes down to is the amount of electronics and the sophistication of the electronics and the complexity of the designs in automotive is just growing at exponential scales right now. If you think about, a car that's rolling off the assembly line today, there's more than 20 cameras in some high-end cars today, and that's going to grow to like 30 in the next couple of years. And so just the sheer amount of sensors around the vehicle, whether that's a camera or short range radar, medium range radar, long range radar, as we start to have more what's called advanced driver assistance features, or ADAS, as more and more of those features get integrated into the vehicle, which are basically being integrated to help the driver realize, that there might be some safety obstacles external to the vehicle, and indicate to the driver, hey, you might be drifting out of your lane, or there's an object behind you, for example, a backup camera, please stop. Or maybe the car will realize it on its own and automatically stop without a human to do that. So there's all sorts of new technologies being integrated into the vehicle, lots of new sensors and cameras being placed around the vehicle. And really what that means is there's a huge amount of data being captured in and around the vehicle. And all that data needs to be basically sent to some sort of compute module to understand what is happening around the vehicle, and then either alert the driver to take some sort of action or perform the action all by itself without a human intervention. And so, and that's why a lot of cars are adopting Ethernet as well, is to be able to transfer that data from the sensor node to the compute module. And so, as there's higher bandwidth requirements, processing requirements integrated into the vehicle to be able to process that amount of data coming over the Ethernet links from the external sensors, the car itself is starting to adopt a lot of high bandwidth FPGAs, common CPU or GPU platforms that we might typically see in a network communication or data center type market is now residing in the vehicle itself. And so really what I'm trying to get at here is there's a high degree of processing power being required in the vehicle moving forward. There's a much higher degree of Ethernet adoption in the vehicle. And what that is providing for us as a timing supplier is the need for more and more reference clocks being supplied to those CPUs or FPGAs or processors or GPUs. So there's a need for more reference clocks, but there's also a need for higher precision reference clocks. When you start talking about higher bandwidth FPGAs or CPUs, there's usually a PCI Express data bus along with that as well. So naturally, there will be clocks needed for PCI Express endpoints, clocks needed for Ethernet PHYs, as well as Ethernet switch SoCs, as well as the processors or GPUs or FPGAs. So in short, there's a growing need for more and higher precision clocks needed in the vehicle. And so instead of just adopting more and more crystals or crystal oscillators, using a silicon-based clock generator provides a much better solution at a lower cost and can provide a lot of extra features that a traditional crystal or an oscillator cannot provide.
Well, that's a good lead in. Before I ask you my next question, I want to share the story, Kyle. I mean, I went to the dealership for my daughter getting her new car, and our car currently has sensors that avoid lane changes and drifting into other lanes. But this was the first experience where I went to the dealership and you're test driving the car, and the salesperson says, "Take your hands off the wheel and just let it go." And that's when the light bulb goes off, right? And you're like, okay, there has to be, serious compute engines inside of this car, because it's almost autonomous. And you mentioned PCI Express. As soon as I see your car diagrams and I see Ethernet and PCI Express, to your point, you're no longer dealing with simple oscillators anymore. You're dealing with synchronous timing sources and long range timing solutions. So it's raised the bar quite a bit. So why don't you talk about our solutions? I love a good trademark. And recently I saw that you and your team came up with a great one. It's called the Smart Clock. I read through it, and it looks like some of the things that you talked about before, now we're adding in some things that are really specific for automotive, like some safety features, redundancy. I would expect that that's driven by the car requirements. Can you share a little bit more about why you guys came up with the smart clock and some of the features that it's introduced?
Yeah, definitely. And so this really came to light when we first launched the automotive timing products to market about a year and a half ago. We went to market strong. We had a list of about 100 customers where we thought there would be a high confidence socket for one of our products based on the early engagements that we had with certain customers developing certain types of automotive electronics. And so, and in addition to that, in timing, we have a very strong relationship with reference design partners. And it was very easy to add, the automotive set of platforms to our reference design partner list as well. And so as we engaged with customers and reference design partners, we started getting some positive feedback on the products, and also some nice to haves as well. And so one of the nice to have that we were consistently hearing about was it would be great to have a redundant input. And the reason customers were concerned about that or would like that type of feature was they said quartz crystals are often, the component with the highest ppm failure rate in an automotive design, which is great. That's one of the reasons we have silicon-based timing products as well, to help minimize the amount of quartz crystals in an automotive design. That's one of our value propositions. But there's always a need for some sort of time base for a clock generator to work, whether that's an input clock from some other source or a low frequency crystal. And so our customer said, well, since you're still operating from a low frequency crystal, it'd be great to have some sort of redundancy feature there, in the case that there is some sort of fault associated with the input reference, whether it be a clock or a crystal. And so we took a look at that and we analyzed the features available in the die and the significant amount of programming capability that we have in the platform. And our R&D team came up with a way to be able to monitor the input frequency to the PLL within the clock generator, whether that be from an external clock or crystal source. It doesn't matter. Whatever the source is to the PLL, we can monitor for frequency stability or monitor if there's even a frequency there at all, and be able to send an output flag signal to an external system safety manager MCU that might be keeping track of the healthiness of the entire system. And so by being able to provide that fault detection capability and let the system safety manager know, hey, something has gone wrong here, would you like to take action? We have this backup reference, this redundant reference available to switch over and therefore keep the clocks running. And so that's what the smart clock feature is doing. It's providing a level of fault detection and healthiness of the reference clocks, and providing the ability to switch over to a backup source if something were to happen that was unexpected. And so the way we came up with smart clock was my colleague in China was visiting a few customers, and he had heard from customers that some other suppliers in the automotive space, not in timing, more in the power area, had used the word smart as a way to describe these fault detection and redundancy features. And so we thought that was a very valid way to describe it, and that's how smart clock was born.
That's great. I think I've seen a lot about it. You've talked to the sales team about it. I'm sure you're getting a lot of interest from customers. How many customers have you engaged with it so far? I mean, is it well received in the market?
Yeah, I mean, I'll go back to even the original family of products, the original launch about a year and a half ago. I mean, everything has exceeded my expectations. This is a brand new area for the timing group. We've had automotive products in the company for a very long time now, right? And a lot of success there. And so it was nice to be able to add timing into the automotive portfolio within the company. But like we talked about earlier, timing devices, specifically silicon timing devices, weren't traditionally used in automotive. It was just a couple of crystals or oscillators. But as the clock trees have grown over the last 5 years, it really opens the door for our type of silicon-based clock generator in automotive. And so we've had a tremendous amount of traction for the devices. Just about every customer that we've engaged with globally, has been very receptive towards the devices. They've obviously given us some homework to do as well, and we've done a lot of testing around emissions to help overcome some of the questions that come from customers. But in general, it's been great. We've had a huge amount of opportunities come our way. Our opportunity pipeline is exceeding our original estimations, and we've actually already achieved some pretty significant design wins with some very well-known automotive tier ones and technology companies globally.
That's great. So that leads me to my next question. So you get these customers interested. Our listeners today, they'll hear about the smart clock. And I know the first question that they always ask is, where can I get support? What resources do you and your team provide them in order for them to get started using these new automotive timing solutions? What can you suggest as far as where they should go or what we offer?
Absolutely, yeah. So one of the first things we did, or I did, was, this is a new market to timing, but more importantly, it's a new type of device to the customer base. So we have to do a level of education of explaining what a clock generator is and why it's valuable to a customer in the automotive space. Educate them, why is it better than crystals and oscillators, and what are the advantages it has. So one of the first things I did was we created the solutions pages on the external website. So under the solutions tab, we have an automotive section, and all of the key applications that we're targeting these timing devices for have an individual page there showing example block diagrams, exactly how the product fits in, some of the key design challenges that are associated with timing, and design guidelines. And then we have a significant amount of new collateral associated with that as well. We have application notes specific to these timing devices all loaded there on that page. So that was one of the first things we did. And then over time, as we're educating ourselves, as we engage with customers, we figure out, all right, this is important to customer A, this is important to customer B, and we start aggregating lists of things specific to automotive that customers are asking for. And I'll give one example. Is it's around emissions and CISPR 25 testing of a clock. And so we've aggregated a lot of feedback from customers on not only the industry standards, but the customer specific standards that they like to see from their suppliers. And we've gone out to third parties and subjected our devices as well as our system designs to those type of tests, and have the results available to customers. And we have that in both slide format as well as PDF format. So there's a lot of information available. We try to put it all on the website as much as possible, but we also have a lot of BU/sales/customer related material available on Sales Guide as well.
All right. Well, why don't I'll take the action. I'll make sure to put the link to a couple of those solution web pages so that the listeners can get access to that. And I'm sure from there they can see some of the other, like the emissions white papers can all be found on those solution pages, correct?
That's right.
All right. Well, Kyle, we've come to the end of the time we can spend on one podcast. There's so much more we could talk about. Maybe you and I can jump on another podcast in the next couple months.
Definitely will.
All right. Well, again, thanks, Kyle. You did a great job. I learned a lot. Automotive timing sounds like it's on fire, and we have a lot of great solutions that our listeners should dive deeper into. For our listeners, thanks again for your time. Thanks for downloading our podcast, and we hope to see you on our next podcast. And until then, everyone, please stay safe.